Okay, class, good afternoon, everyone. For today's class, we'll talk about simple and compound interest. We'll divide this into two parts. So part one is the simple interest. Part two is the compound interest. So we'll do something different today. So we'll connect the keywords and key phrases to the key formulas. So now we have key formulas. So of course, in part one, the main keyword or key phrase there is simple interest. And for part two, the main keyword key phrase there is compound interest. So let's see the key formulas. So there, you see the formulas, right? So these are the key formulas for simple interest. So these are the key formulas for the compound interest. So P here stands for the principal, the amount of money that you borrow, okay, from an institution such as bank or from a person, okay. And then if you cannot pay the bank immediately with this principal, or a person with this principal, so you'll enter into an agreement, right? Like for example, you will pay by installment. But if it's by installment, this P will increase. It will become A. Okay, so A is the total amount to be paid because there will be an interest. So A is actually, aside from this formula, A is equal to the principal plus the interest. Okay, that's why the interest, you can obtain it this way. Also, interest is equal to A minus P. Now, this one will increase because of the rate. R is called the annual rate of interest. So please write that word, annual rate of interest, to be applied on this P, which is the capital, for a number of years, which we denote as T. Okay, class? That is why when you apply this 1 plus RT, we multiply it by P, so A will be greater than P. It should be because you will pay, because you're not able to pay the principal, so you have to pay a higher amount, which is equal to A. Okay, so that's what we're going to tackle today, how to compute the A, the P, or even the R or the T. So T is the number of years, okay? T is the number of years. So the I in particular, we can also get I this way. I is equal to PRT. Okay, class? So now, for the compound interest, we also have three key formulas. But the major key formula here is this one, because you can obtain this from here, actually. Okay, so now there's a similarity between the two. So A is also the total amount to be paid, and then P is the principal. The difference between the two is this one, the I and the, between the I and the R, the N and the T. I stands for the periodic interest rate, because here, here you apply annual interest rate on the principal, here we can apply not only annually, but we can also apply the interest on the principal semi-annually, quarterly, monthly, okay, and so on and so forth. So that's why we just call this, in a more general term, we call it the periodic interest rate, because the periods can vary. Unlike here, the R is always annual rate of interest always. And then the N here is related to T. If T here is the number of years, the N here is the number of periods. But for you to be able to get the number of periods, you have to know your T. Okay, you have to know your T. And the other variable, we need to say that variable has to do with the number of periods in a year. Number of periods in a year. For example, if you apply the interest rate on the principal monthly, so the number of periods in a year is 12 because it's monthly. Okay, so if it's semi-annually, how many periods do you have in a year? Two periods. So the number of periods here will be affected by that, and also by the number of years. So for example, if you will pay the A, okay, you will pay this amount for 2 years, and then the agreement is monthly. So that means how many periods you have in a year? 12. But it's 2 years. So what's the total number of periods? So 12 times 2, 24. So N is 24. Okay, the N here is 24. Unlike here, the T is 2 because T is the number of years. Whereas here is the number of periods. Although the same, right? 2 years, 2 years. But the thing is that this one annually. You apply the rate of interest, this annual rate of interest on the principal annually. That's why the T is just 2. Whereas here you apply this rate of interest, which we call the periodic rate of interest in general, on P monthly. That is why 24, because 2 years, right? 2 times 12, 24. So in a way, you know already how to get, but we have a formula. But the formula is like that. Okay, so that one. Then the I here is also related to R. But again, it's connected to that number of periods in a year. So for example, the R here is 0.04. 0.04. So meaning to say 4% interest to be applied on the principal. So you write here 0.04 because this is annual. Okay. Unlike here, for example, the number of periods in a year is 4, meaning to say quarterly. So your I here will be 0.01 because you divide. So 0.04 divided by 4 is 0.01. So this will become 0.01. Okay. So you notice the I and N are related to the number of periods in a year. It's affected. If here you divide, here you multiply. Now, anyway, that will become clear to you later as we discuss examples using Excel file and the computational class. So now, even though these two are the same variable, but their values are different. And also the P. The P here can be the same. Actually, if the P are the same, the I and the R are the same, but the T and N are different, then this one will have a higher value than this one because it's compound. Later, you'll see why. Now, to get the interest, we don't have a particular formula for the compound. So we just have this, which is similar to this. But again, they're different class. I'm sorry. So again, they're different, okay? Because this one, you base it on the compound interest. The interest here, you base it on simple interest. Now, what is this thing here? This thing here is related to this. No? If this one is general, this one is more specific. So this one is annual rate. We consider here the annual rate of interest. So the I here is annual rate of interest. Similar for this one, right? The R here. So the I here is annual. But you can obtain this from here. Because remember, we also have annually here. Okay? So I mentioned this here because we have an example wherein we will use this formula. But later, you can forget this. Now, once you learn how to use this or this one, it's okay to forget this because you can get this one from here. Later, you'll understand. That's why you can just remember this two. This formula for the compound, this one, and this one for the simple. Now, we have a mnemonic device for you to be able to remember, or not really remember these formulas, but it's because it's okay for you not to remember the formulas as long as you know how to apply them, especially how you apply the Excel file to this. Since I'll be using this, so I just want to say it in one word. Instead of telling you the formula, I just say it in one word. Like for example, I call this APERT, APIN, APIT. It sounds funny, right? Because this one sounds like EPIT, right? This one sounds like NIPIN, okay? This one sounds like APERT, right? Like fart. So anyway, other thing, it sounds funny so that you can remember them because I will use this later. I'll just say, okay, APERT, then APIN, APIT, okay? So these are the formulas, the main formulas that we will use for this topic. So let's go to part 1, which is simple interest. So what is simple interest? Simple interest is an interest computed based on the original principal during the whole life of investment. So I've mentioned already to you the formula, I is equal to PRT, right? And then the meaning of these variables. But let's be more specific with rate. Rate here again is the annual rate of interest class. Annual rate. For the simple interest, we consider the annual rate of interest. Unlike in part 2, which is the compound interest, we can consider others. Like for example, semi-annual rate of interest, monthly rate of interest, quarterly rate of interest. But in general, we call it, remember, we call it periodic rate of interest in part 2. For this one, always annual rate of interest, okay? This one, let's be more specific again, because in part 2, yes, we will use also T. However, we will use more of the N there, which is the number of periods. Whereas here, we'll use the number of years. Okay, the number of years. In effect, it's also number of periods. However, we'll always use number of years here. So there's no use to use the number of periods. Unlike in part 2, we have to be more general. Number of periods, because we can have not only annually, but we can also have semi-annually, monthly. So in general, we just call N number of periods. Whereas here, we only talk of annual rate of interest. So it's okay to call T as the number of years. But in general, we can say number of periods also. Okay, class? Because, okay, anyway, that will be the next topic. I'll just talk about the next topic next time. So anyway, okay. So more about the terms. I already mentioned to you about the A, which is the amount, total amount to be paid, right? total amount to be paid. But you can also call it maturity value, which we denote as F. So I erase this because we will use A so that you won't get confused. No, but it has the same meaning also with F. Okay, so that for consistency, when you hear the word when you hear this variable A, capital A, when I say capital A, I'm referring to the total amount to be paid. Okay, total amount to be paid. So I mentioned this at the beginning that A is equal to P plus I. Principal plus the interest is equal to A. Now let me show to you how to get this formula, the A part from this. It's easy, algebra. So since I is equal to PRT, so replace I by PRT, right? And then factor the P. Okay, so you get this formula. A part for the simple interest. Okay, class? So you notice, class, when you say A part, so the letters are pronounced well, right? And the others are sounds only, like the T and the R, but the A, they are pronounced A pert, but the R and T are sounds. Okay, you don't really have to memorize, but again, I'll be using that key, that mnemonic device. So when I say A pert, I'm referring to this formula, class, huh? And later also, when we use the Excel file, I'll be mentioning this A pert, okay? And the other two in part 2, the A pin and the A, okay, the A pin and the A pit, okay? So anyway, so more about the terms, and then later problems, class. Now, sometimes the T is not given in the number of years, instead number of days. So if T is given in number of days, then you have to convert it to number of years. There are two ways. You can use this or this one. So if you use 360, number of days divided by 360, we base it here on the approximate time, because on the approximate time, we assume that each month has 30 days. And that interest will be called ordinary interest. Okay, class? Ordinary interest. The other one, the exact interest, you base it on the exact time, because as the name suggests, it refers to the exact number of days found in the calendar. But of course, this will become 366 if it's a leap year, right? Okay, so you have to adjust. Okay, class? So now this has importance on businessman, because which do you think is larger here? D over 360 or D over 365? You remember in high school, you learned that if fractions have the same numerator, but the denominator are different, the higher the or the lower the denominator, the higher the fraction. So this one is higher than this. Since this fraction is higher than this or greater than this, so this interest here is greater than this. So ordinary interest is greater than exact interest. So usually businessmen use the ordinary interest because it will give them a higher interest. Okay, class? That's it. Actually, all about this term. Now, let's go to problem. I guess the next one is problem. Okay, it's a problem. Okay. John borrowed $3,000 for 4 years at 5% interest rate. How much interest is that? So again, in problem solving class, right? There are 4 steps. So understand the problem and then devise a plan. In devising a plan, our plan here or strategy here, use a formula. So this formula. But for us to be able to implement the plan, which is third step, we should be able to identify which one is P, which one is R, and which one is T. Okay, class? So here, what do we have? P is the principal, so 3,000. The R is 5%, so we change it to decimal, 0.05. T is the number of years, so 4. Just multiply using calculator. We get $600. Now, the A plus I, the A is equals P plus I. That's the total amount to be paid, including the principal. Okay? So that will become what? $3,600. Okay. For review class, let me show you the remember the 4th step in problem solving is review. Okay. One way to review is repeat the process, right? Repeat the process. You just have to make sure that they are right and so on and so forth. Another way is we use a technology like Excel file to review. In fact, you can replace the solution by Excel file. Instead of using the computational or manual, just use the Excel file so that for sure, all you have to review is the formula, if you're doing the formula correctly. Okay, so now let's go to Excel file, another way of computing then using Excel file. I'll teach you how to create class the formula, because the problem with this is that we don't have formula here for, I may be wrong, but I haven't seen formula for simple interest. Remember formulas, the one we did in linear regression and correlation, right? Insert function, but I can't find here, there's none. I can't find the simple or compound. Okay. Anyway, it's also good for you to learn how to create formula, because these functions here also use formulas. They're just hidden because they're programmed here, right? So So in a way, we're doing a program. We're creating a program in a way, in our own way. Okay. So now let's do it. So the formula for interest is PRT. So these are the given. Okay, class. Better to write the formula here, class. Okay, but if the formula is simple, no need. Just put the just apply here. This one, you notice this one. Okay, how to do this, class? Okay, let me erase for a while. Okay, let me erase. If I erase this, no more answer here. I'm sorry. No answer. Okay, no answer because I erase it, right? Okay. Now, in Excel file, you have to know the notations because in Excel file, the asterisk here means multiplication. You cannot write PRT. You have to put P times R times T. However, when you create the formula, you don't write these variables. Instead, you have to write the location where P is located, R is located, T is located. For example, this one, we want these values, right? We want to multiply these three values. So instead of writing PRT, we have to write the location. So no need to write I, just to write equals. Okay, where is P, class? Here. So how do you put the location? The column and the row. So this is A4. A4. Okay, so you know it because it's highlighted. Okay, you know that it's correct because it's highlighted here because this is what you want. You want to multiply the 3, right? So A4 times B4. This is B4, right? B4. So you notice column and row. And then times C4. Okay, class? And then enter. Oh, so that's the answer. Isn't it the same with our answer there? $600. Okay. Now, if you want to repeat the process up to here, just copy paste. Okay. Copy. Since I have values here already, I will not do it. I will not do that anymore. So I'll just start here and then drag down. You drag it down. It's up to you, up to 1,000, up to 1 million. It's up to you. And then enter. Oh, see? Why did I get 0 here? Because Excel file reads this as 0, 0. The blank, the Excel file reads it as 0. Okay, that's the reason 0 here. Well, once you put the values, of course, it will be non-zero already, right? Non-zero. Okay, how about for the total amount, the A? Because I already created the formula there. So I just wrote this equals A4 plus D4. You notice they're highlighted, so you know you're right. Because we want to add this, the P and the I. So the location of this P here is A4. The location of the I is D4. Okay, and then enter. That's it. Now again, if you want to copy here, so like that, copy, and then like that, and then drag it down up to here, and then enter or paste. See, you notice. Now, if you don't want to use this, you want to use this formula. Okay, let me go back. This one. You can use this. For example, you don't want the I, you only want the total amount to be paid. So don't compute this. You can go to this one. As long as you have the P, the R, and the T. If you don't need the I, you only need the A. Okay, so let me show you. So here is the formula. So you notice I put the asterisk, right? Because this is multiplication. So if you look at this, look, you notice A4, they're highlighted, right? These are the values we need. So A4 asterisk parenthesis 1 plus B4 asterisk C4. So you have to actually they're customized, class, right? What do I mean by customized? Okay, let me. Okay, what do I mean by customized? Look at this one. This I'm sorry, what happened? Something happened. Okay, there. Look at this. So you notice it's not anymore 4, it's 5. It is customized because it's the exact location, but we want this value. So where is this located? A5. Because if it's A4, it's this one. Okay. What's good is that when you copy it, the customization will follow. Okay, the system will customize it actually for you. So that's the good thing. Look at this. So I'll copy. I can copy anywhere, class. I don't really have to copy this. I can copy this also because the formula is already here. You notice it's already there. So it's okay for me. Even this, I can copy this if I want to because it's customized already. So let me copy this one. Copy and then drag down. I'm sorry. So there, it is moved. Oh, wait, I think something went wrong. So copy again, copy. And then, oh, what happened? Okay, copy. And then there. Yeah, the problem is the dragging down. Anyway, so there's 0, you notice. So what do I mean by the customization is will automatically follow. So here, you notice 13 already because you're referring to this. But where did we copy this? We copied it from here, I guess. Oh, so this is 9. Okay, so the customization will follow. It will also be copied, right? So anyway, so there. Okay, so I think you know already how to create, right? So the important here is the asterisk class hub. Because if you don't use asterisk, okay, for example, this one, I don't use asterisk. There will be an, I guess, error. I may be wrong. Let's see. Oh, see, there's an error. So the Excel file cannot understand, okay? Cannot understand. So let me put the asterisk. Now also class, the Excel file only recognizes parentheses. It cannot recognize the bracket. So let me use the bracket here. Bracket. You know what bracket is, right? This one. Oh, let me use that. There is a problem also. Oh, see, it's wrong. That is why only use parentheses. Only use parentheses. Remember, we use grouping symbols. Sometimes inside the grouping symbols, we have grouping symbols. And then inside that, we also have grouping symbols. So our style is we use different grouping symbols. Here, you just use parentheses, this parenthesis. So you can have parentheses inside parentheses, but then parentheses inside parentheses. You're going to have that. Yeah. So I don't know if you have an example of that here. Okay, class. Okay, that's it. So now, let's have another example. Probably this is another example. So Sarah deposits 4,000 at the bank at an interest rate of 4.5% per year. How much interest will she earn at the end of 3 years? Okay, so again, PRT, right? So the P is this one, the R is these, and then this one is the T. Using calculator or manually, you get this one, 540. So what is the A? 4,540. Now, if you use Excel file, so this one, right? P, these are the given. You want to find this, right? The I and the A. So just plug in 4,000, 0.0453, right? 0.045. Yeah. The decimal of this is 0.045 and then 3. And then create the formula. So since I already created, that's why we have the answer. So there. A5 asterisk B5 asterisk C5. If I were your class, why don't you try it yourself? If you have Excel file, why don't you do it now? So that, because you learn by practice, by experience. So if I were you, you solve together with me, okay? Let's do this together, something like that. And then look at the, look at this, the A. Okay, there. So why don't you try it there in your place? So is equal to A5 plus D5 because we want the P and the I. Okay, it's customized, right? Because it's in the 5th row. And then if you want to do it with the rest, then just copy paste, right? Okay. If you want to use this formula, yeah, you'll get the same answer, but different formula, right? Okay, class. So now let's have another example. Oh, you can try it there. If you have the Excel file, why don't you try it, class? Okay, so so here Raymond bought a car for 40,000, but he took a 20,000 loan from a bank at an interest rate of 13% per year for a 3-year period. What is the total amount, interest and loan? So interest and loan, meaning to say the A, interest, I plus P, principal plus I. So you want to compute for the A, the capital A, that he would have to pay the bank at the end of 3 years. So here, class, only the 20,000. So probably the other 20,000 from his own packet, right? From his own packet. So that means the principal is 20,000. So class, this is an example of a problem wherein we can just use the A PERT, the A PERT. Okay, but this one, but you can also use the, you can compute for the interest first, and then you add the interest to the principal. We can also use that. Okay, but here, since the question is only about total amount, it's also fine to have that only, the total amount. No need for the interest. Why? Because we have a formula for that, right? The A PERT. Remember the A PERT? Where is that? This one. We can just use this, right? Because we only like, we only want the total amount. That's why, is this the problem? Yes. Oh, we obtained the same answer. Just write the given 2,000, 0.13, 3. 20,000, I mean. 20,000 the principal, 0.13 the interest, annual. The number of years is 3. We get the answer. Even if you don't do this 2. Even if you don't do this, you will get the answer because you're only after the capital A. But another solution is you get the I, and then you add the I to the principal to get this. Okay, class? So again, you can see the formula right there. And then the formula here, there. And the formula here. Okay, but again, you don't have to write it again, class, huh? For those who came in late, you only have to copy and paste. Okay, copy. You can copy this or this one, even this, and then paste there, something like that. Okay. So anyway, so more problems. Okay, this one you're asked about the interest and the capital I and the capital A on a loan of 10,000 for 3 years with an interest of 10%. So manually or using calculator, so you got 3,000 and then the A is 13,000. Now, using the Excel file, so we have this one, this result. Where is that? This one. 10,000.1 because it's what? 10%. Then 3 and then there, 3,000, the same answer. 13,000 and 13,000. Okay, same answer. So now, okay, it's not always the case that you'll be asked to get the capital A or the capital I. Sometimes other variables because this one is a literal equation. When you say literal equation, you have a lot of variables in that equation, literal letters. So you have a lot of letters in that equation. So you learn this when you were in high school, just like linear equation. You learn linear equation. You also learn literal equation. Usually formulas are literal equation. So you have to apply your algebra skill here. Algebra skill, meaning to say solving one variable in terms of the other. For example, solving R in terms of the other. So if you do that, you get this. Because why? Because that's what the problem wants. What was the interest rate? The annual interest rate. So we should have a formula for that, which we obtained from here. So what do you do algebraically? Divide both sides by PT over PT over PT. That's why we have here I over PT. So this is the computational, the manual, or using calculator. So just know the given and then substitute into the formula. And then you obtain this answer, 3.75%. Or this one, right? Not this one, class. I forgot to erase this, okay? Because we have an exact answer. So just put the exact answer. No need for this. 3.75%. Now, if you use Excel file, just know the given, okay? This one. So you have to create another formula. So this is very critical, class, because if this is wrong, of course, the created formula will be wrong, okay? So what's the formula here? Look. So there. H4 because I. And then divided by I4 because of the P. I4. And then J4. Then enter. You get the answer, which is 3.75. Okay, class? This one, I'm just justifying that this is wrong. This is not correct. Okay? Because if it's 3.7, remember if you round this off, this is like 0.037. The interest will be wrong, 88. But the given in the problem is 90. That's why better 3.75%. Okay, class? Now let me show you another Excel file. Another sheet in the Excel file. Where's that? This one. This one, class. So look at the simple interest. So this is the formula for A. So which we discussed already. And the given to get the A, the P, the R, and the T. Now, sometimes you're asked not only the R, the P, right? So this is the formula. For, P is equal. So you have to apply your algebra skill here, right? So this algebra skill here. So if A, so you notice I did not use asterisk because I'm just trying to find the formula, right? So how do you find the, where is that? I'm sorry. This is for the R and this is for the T. For the P, class, it's easy. It's just easy because just divide both by 1 plus RT, right? That's why P is equal to A divided by 1 plus RT. If the question asks you about the principal. So what will you put here? You can write here the given. Actually, you can write the given first and then the answer, then the unknown. But I want the first one to be the unknown, okay? Because I have a reason for that. Because I want this, because of this one, the A part, right? That I mentioned to you, the A pit and then the A pin. I want to be able to follow that mnemonic device. That's why the unknown, I make it the first one. And then the given here, okay? So let's try. Okay, did you see the formula that I created? Base here. So this one. Why did I get 0? Because ART are zeros, they are blanks. So 0 over 1 plus 0 times 0 is 0. So 0 divided by 0, I'm sorry, 0 divided by 1 is 0. But if I put values, it will change, right? It will change. So 3, 4, for example, 6. Oh, look at the, see, there's an answer, 0.08. Okay, it will change, of course. No. Anyway, this is an example. It's not, it's not realistic. Let's make it 3,000. Okay, 3,000. And then the 4 is 0.04. 0.04. And then the T is 6 years. Oh, there. It's more realistic now. Is it? Yes, because this one is 30,000. This one should be greater than the principal. This is 24,193. Okay, this is an example. Because sometimes the problem will ask for P. What if the problem will ask for R? So you have to do you have to solve for R. So here's the algebra part. Okay, so distribute P plus PRT and then transpose A minus P is equal to PRT. Then divide both sides by PT. So R is equal to this. And then this one you put here. And then you notice why this is undefined. Okay, let's look at the formula there. Because T is equal to A minus P, right? Where's the A here? Where's the P here? Where's the R here? So what's the location of the A? Not the A, not this A, but the A here. It's covered. Where you will put the value. It is B12 because row, or B12 minus, where's the P? This one. You can see it, right? It's highlighted. The other one is covered by this, but it's also highlighted here. So the P is here, it's highlighted. So we know the location of this is what? Because you will input values here, right? So that's why it's important you put the headings, class. Okay, the headings, the column headings. So this one is what? C12. Oh, there, C12. And then what's the D? D12, okay? Where's the R here? So D12, okay? So how come it's undefined? Because they're all zeros. Remember, a number 0 divided by 0 is undefined. But if I put values here, of course, there will be an answer. Okay, look. Let me put values. Let's be realistic. So 2,000 or 20,000. Let's make it 20,000. The principal, let us say 9,000. It should be smaller class, right? Smaller. And then the R, let's make it 0.0 something. 0.09. Oh, see, there's an answer already. So this one means 13 years, 13.5, 13.6 years, right? Okay, so once you have the formula, it's easy because you can just copy and paste, right? Or copy and then paste. Okay, so they're undefined again. But if you put values, there will be an answer, right? 30,000, and then what is this? 7,000. I'm sorry, 7,000, and then 0.01, for example, 0.01. Oh, see, we have an answer. 328. It's not realistic also, right? 328 years. Anyway, 328 years. Why is it that? Anyway, let's change it to be more realistic. So let's make it 3,000. And then this one is, so it cannot be because it's negative, right? So because the principal should be greater than, the principal should be less than. So let's make this 700. It's not realistic, still not realistic. So probably let's make this 0.00001. It's bigger. It's bigger. So 0.1 probably. I think that's okay now. 0.32 years. Anyway, just an example, right? So for this one, the possible to be asked are what? These variables: P, the A, the P, the A, the P, the R, the T. Right, class? So you should know the formula. You should know how to express one variable in terms of the other. Okay. So that's it for this one, the simple interest. Let's go to compound interest. So I don't think we'll be able to. Now for compound interest, okay, let's see the difference with the simple interest by considering this problem. Suppose you put $5 in the bank. The bank pays 4% interest a year, and this is credited to your account at the end of the year. So you know, remember this, the APIT, and then this one is the APIT. The APIT is the formula for the simple interest. This one is for the compound, no? Annual, because we also have APIN for the more general formula for compound interest. But this one is more specific, annual. Since this is annual, so let's make this annual so we can compare the values. But we already know, right? We already know that the interest or the capital A here will be greater than, I'm sorry, for this one, the capital A or the capital I here will be greater than this one, the A part. Okay, but let's consider examples. Okay, let's consider examples. So let's have this sheet here. Where's the example? This one. Did you see this? Let's look at the simple interest. So what's the principal? 5. What's the rate of interest? 4%, 0.04. So let us say 1 year, class, 1 year. So what will be the total amount to be paid? 5.2. Now let's compare it with APIT. APIT, the annual interest rate formula for the compound interest, 5.041. Okay, the answer is also the same. You notice? However, let me show you, since it's here already. Let me show you what if it's APIN. APIN, meaning to say also 5, the principal. However, here semi-annually. For example, you apply the interest rate on the principal semi-annually, meaning to say how many periods in a year? 2. So you divide 0.04 by 2. That's why we have a formula here. You notice the formula? The J here is the 0.04. The M is the 2. Because if it's annually, 1. If it's semi-annually, 2. So 0.04 divided by 2, 0.02. Okay. Now why 2 here? Because N is the number of periods. And this is the formula. So if it's 1 year times 2, 2. Because in 1 year, you have 2 periods, so 2. But you notice the answer is different na. It's already 5.202. And it's greater than this one. And also from this one. Okay, now let's focus on this 2. Let's focus. I just showed you how to apply the APIN. Okay. Now let's focus on this 2. Now look, you go to T equals 2 years. It's different now. The answer here is 5.408, but the same given. You notice the given the same, 5.042, 5.042, but the answer is different. Why? Because this one, there's an exponent. By the way, class, this is the notation for the exponent. This one, you raise it to T. This one, you multiply by T. So this will become bigger, right? That's the one reason why the total amount and the interest, are greater than the ones here in simple interest, because the T is an exponent, whereas the T here is not an exponent. It is a factor. You multiply it. So 5.4, this one will become 5.408. Now look at the 3. So it's greater than also, but the same given, you notice the same given. Okay, because of the exponent T. Okay, and this one, look. Okay, now you understand this better considering this. You consider this. You notice the same class. That's why the same color. I use color coding. You notice the same values here and the same values here. But the only difference is the TY, because here we apply every year. We apply simple interest here every year. So you notice compound interest, we also consider simple interest. Oh, look at this. Okay, let me show you. So for the first year, the principal is 5, but the interest is 0.04, right? So 0.04 times 5, what's the answer? 0.2. So how do you get the A? Principal plus I. So what's the principal? 5. What's the I? 0.2. So 5 plus 0.2, 5.2. So now, class, in compound interest, that will be the principal. That will be the principal. Unlike in simple interest here, the principal still be the same, still 5. However, in compound interest, even though you apply the simple interest formula, there will be an effect because you notice the principal is changing every year. The principal is changing, it's increasing, you notice. Whereas in simple interest, it's fixed. That's why the rate here is fixed. The interest here is fixed. You notice always 0.2 plus 0.2 plus 0.2 plus 0.2. Unlike here, it's not 0.2, it's increasing. Even the interest is increasing. Why? Look at this. What is 0.04 times 5.2? What is 0.04 times 5.2 times 1? It's you use your calculator. You try it, class. 5.2 times 0.04. Oh, let me show you your answer in the chat if you want. Okay, let me see if you have an answer. Otherwise, the answer here is you can check it if it's correct. The answer is 0.208. 0.208. 5.2 times 0.04 times 1 is 0.208. You add it to 5.2. What is the answer? This one. Now, for the third year, this will be the principal again. Then you continue doing that. Then 0.04 times 5.408. Okay, the product, you add it to 5.4, you get this answer. Then this one will be the new principal again. So you notice, you apply interest on the interest. You apply interest on the new principal. So that's the reason the total is also increasing. Whereas here, it's always 5. Every year, you just multiply 0.04 times 5.02. Then I add something like that. I add it here, 5.4. So I got 5.6 like that. 0.04 times 5.02. 0.2 again. So I add 5.2 so 5.6. So I'll have 5.8 like that. So it's fixed. It's constant, right? Whereas here, it's not constant. It's increasing because of this t, the t here. It's exponent, whereas the t here is a factor. Okay, class, did you see the difference now why the compound interest is higher than the simple interest? Even though you apply simple interest inside, but you apply it every year with the new principal, Unlike this one, you apply the simple interest on the same principal every year. For this one, you apply simple interest on the principal, on a different principal, increasing principal actually. The principal is increasing, right? You notice the principal is increasing every year. And you notice you don't only apply interest on the principal, but also on the interest. Why? Because there's an interest here. What's the interest here? 0.2. So in effect, when you multiply, you also apply on the interest. So see the effect of that. That's why it's called compounding. There's a compounding effect. Okay? There's a compounding effect. Okay, class, that's the difference. So now let's focus on solving problems. Okay, class. So now this one. So this one, class, it's still APIT, right? You apply APIT, but you can also apply APIN. APIN. Okay. So what's the principal? 250. The I is 0.02 because here annual interest rate, and then the number of years is 1. Okay. So if you apply here, there, 250, 0.02, 1. Then the answer is here because the formula is here, class. Huh? I just follow this formula. The A is equal, the APIT. I just follow this. And then notation in Excel file. I use the asterisk and this caret, I think caret, for the exponent. So I just follow. But of course, the others are customized. It depends on the row and the column. Okay. But to be able to do that, I just copied this one. Copy and then paste here. Okay. So you just have to create one. Actually, this is what I created. And then I just copied and pasted. Okay, that's what I did. I just copied and pasted. So I just created one and then copied and pasted. Okay. I'm sorry. That's why we got this answer. These are the given. So it's all about knowing the given, input, and then copy paste the formula. So I can copy here and then paste here, something like that. Okay. Then put the values here. Okay, class. That's how easy it is. Now you can use APIN here. Oh, look at that. If you use APIN, where is that? The 255. There, you notice the 255. The same answer, class, but different approach. Look, why different approach? Principal 250, whereas here 0.02. Why? Because the interest given in the problem is 0.02. It's annually, so M is 1. So what's 0.02 divided by 1? 0.02. That's why the same answer here. Okay. Now look at this. What is the number of periods? 1. Why? Because T is 1 year. What is M? 1. 1 times 1, 1. That's why it's 1. So that's why you will get the same answer. That's why it's okay, class, to forget this. You can just use this, the APIN. But I use this because it's given in the problem. And besides, I compare it with the annual, with the simple interest. No? So in effect, you can just have to remember this and this one, the APIN and the APERT. Okay? So now, let's have another example. Now, here you can see the APIN, right? The APIN. Because this one is the I, right? J divided by M. The N is this, MT. Okay, did I apply this? I think I did. 5 pesos and then 0.0. But this one is quarterly. 1 year, right? Quarterly and then 1 year. So the M here is what? Quarterly. M is 4. What's the T? 1. Okay. What's the J? The one J is actually annual rate of interest. Usually in the problem, you'll be given annual rate of interest. So that is 0.04. Now let's look at the Excel file. Where is that? So here, class. So principal is 5. Why 0.01? So remember, 0.04, 0.04 divided by 4, divided by quarterly 4. 0.04 divided by 4, 0.01, because it's quarterly. Okay? Now this one, why 4? Because the number of years is what? What's the T? 1. What's the M? 4. 4 times 1, 4. That's why 4. So the answer will be this one. Okay, class? Now, look at this, class. Look at this. You notice all the same, 0.02, 0.02, 0.02, 555. However, the number of periods increasing. Therefore, the interest is also increasing. So in other words, the higher the number of periods, the greater the value of A. Okay, class? Did you notice that here? Okay, anyway. Okay, I think we have more examples. Yeah, more examples. So this one, what is this? It's annual, class. By the way, class, if it's not indicated here, it's understood annually. For example, you did not see, it's not obvious here, right? That there is semi-annually or quarterly. Then it's understood it's annually. That's why you notice it's 1, the M is 1. What is the J? 0.09. So 0.09 divided by 1 is 0.09. So that's our I. So if you use Excel file, 0.09 is the I. And then this is what? N, number of periods. So what's the T? 3. Annually, 1. 3 times 1, 3. N is 3. 3 periods. And then principal. Okay, class? And then this is the answer. Same answer as the Excel file. Look. Where? There. Here, class. You notice? 250.093. The answer is here. The same answer. So look at the formula. So again, I just created in this column. Actually, in this column here, before this, here up to here, I just created one formula. I just copy pasted. I think this one, I just created the first one and then copy pasted. So there. Okay. Okay, class. So now, next. Okay, this one is like to generalize, class, what we discussed. So generalization, I think I mentioned this already, that A pin, then I is equal to J over M, which I already mentioned. N is equal to MT. And then I just showed to here that A pit, you can get A pit from A pin because M is equal to 1, right? If M is equal to 1, so there, J divided by 1, that's J. So J is equal to I. That will be your I. Okay, because remember I is equal to J over M. So if M is 1, that will become J is equal to I. So I just make this I. Now how about the T? Since M is equal to 1, 1 times T, T. That's why it's okay not to remember this. I just showed to you that we can get this from this one because this one is general formula, the A pin. That's why I asked you to remember A pin only. Never mind the J over R or the MT. As long as you know how to get the I and the N, that's fine. That's why I just remember this as A pin. Okay. So in A pin, it's more general. There's annually, semi-annually, quarterly, and so on and so forth. Unlike this one, it's only annually. That's why you forget this. Just remember this. Okay. What are these? This is for the N. Because remember, N is equal to MT. So if M is equal to 1, T is equal to 1 here. So just multiply. 1 times 1, 2 times 1, 4 times 1, 4, 12 times 1, 12. So if it's semi-annually, M is 2. Quarterly, M is 4. Monthly, M is 12. Because here, you're considering the number of periods in a year. Okay. And then to get the N, again, multiply MT, right? 1 times 2, 2, 2 times 2, 4, and so on and so forth. Okay, class? So now, I think this is more problems, right? So this one, our focus now is A pin, class, A pin. So if you're finding what do you want? The interest and the compound amount, right? So let's find the compound amount first. Because we don't have a separate formula for interest, right? If you want to get the interest, unlike in part 1 class, we can get the interest even without the A. What's the formula for I in part 1? The simple interest. Isn't it I is equal to PRT? Whereas here, class, in part 2, you have to find first the A before you can get the I. Once you have the A, what is I? I is equal to A minus P. Okay? So now, to get the A, we apply the A pin, right? A pin. Where is the... So this one, A pin, right? So this is the principal. This is the 1. This is the I. This is the N. How did you get the I again? Periodic interest rate. This one is the J, 0.08. Quarterly, 4. So 0.08 divided by 4, 0.02. This one. And then what's the n class? Number of periods. So again, if here you divide, for the n, you multiply. So this one, change this to what? Change this to number of years. So 5.5, because 6 months is 6 over 12, right? 5.5 times 4. So you notice 5.5 times 4. This one, divide 0.08 divided by 4. So both of them are related to m. The m is what? 4. Okay, class? So again, it's okay if you forget the variables as long as you know how to get the I and the N. Okay, class? So now, let's use the Excel file. Just substitute. The P is 54,600. The I is 0.02. The N is 22. That's how simple it is when you use Excel file. So let's find out. Where is that? For 54,600. So there. You notice that, class? 54,600, 0.02, 22. The answer is the same. And look at the formula. Okay, it's patterned here. But again, I just copied it and pasted. Okay, I did not write this again, class. I just copied and pasted. And I created this. I think I created this first and then copied there. I can do it once, or it's up to you. Okay, class. So now 84,410. The same, 84,410. Then to get the what's that? The interest, A minus P, right? A minus P. You get this, the interest, 29,810. Okay, class. So another class, if you want to do this manually, for example, you want to do this manually, you want to find the n manually. So again, in 1 year, how many periods? 4. So multiply this by 4. 4 times 520. When you say quarterly, what does it mean? Every 3 months. So how many 3 months do you have in 6 months? 2. So 20 plus 2, 22. So you can do it manually if you don't want to do the conversion of 5.5 times 4. Okay, class. So now next. So again, this one is A pin, still A pin. You're asked to get what? So again, the A, the capital A and the I. Okay, the capital A and the I. So again, if you will apply the Excel file, all you have to know is what? The I, the N, and the P. Where's the I? How will you get the I? Okay, let's not look at this. Let's look at the problem. So to get the I, quarterly 4. So this is the J, right? So 0.13 divided by 4. That's the I. 0.13 divided by 4. That's why you have it here, diba? 0.0325. And that I will put in the Excel file. Now, how do you get the N? Because that's what we need, right? So the 12 times 4. 12 times 4, 48. Okay? So that's how easy. Because this one looks complicated, right? Because so many variables. But it's okay if you want to do it this way, that's fine also. But for me, as long as you know how to get the I and the N and the P, then substitute into the, what is this? Into the Excel file. Where is that? This one, 25. 25.0325, 48. You get the answer there. The same answer anyway. That's the formula. The answer is what? 11,605. The same. Okay, class? So now next. So this one, actually this problem asks for what? The interest. But there's no interest. So again, to get the interest, just subtract. Did I get it here? Let's see. Yeah, I have it here. If I want to get the interest, look at that. I just subtract the 2. But I did not have I don't need the pattern because these are patterns, right? The pattern. I don't need because it's simple. How do I get the interest? Just subtract the 2. Just subtract this 2. So K12 K12 minus L12. No need for pattern. I can just do that. Type it here and then click. So that's the answer. That's the interest, 9,000. So that is being asked here, right? Find the interest as well. But it's not given here. Okay, anyway. Again, the capital F class is the capital A. Okay? So now next, what is this? This one, so again, you'll find the A. If you want to find the I, then again, you subtract the A and the P, right? So again, it's just routine class. It's routine. Even if you don't look at this, just look at the problem. So we need the P, A pin class. We need the P, the I, and the N. Where's the P? This one. Because we want the A, right? This is the P. Where is the I? It's not here. You have to compute. Semi-annually, 2. To get the I, divide the 2. 0.12 divided by 2, 0.06. That's why you have 0.06 here. If you want to remember the formula, there, I is equal to J over M. Okay? So now, what is the N? Oh, here, look at this. 5 times 2, 10. That's why you have 10. Okay, if you don't do this one, go to the Excel file. Just substitute those values into the Excel file. So 3,700, where's that? Oh, so there. 3,700, 0.06, 10, you get this answer. Same answer. 6,626.14. Okay? And then, if I want to get the interest, I'll just use the Excel file. So there, the same answer also, 2,926.14. Okay, class? So that's how easy it is. Huh? Look at the formula. It's customized because 14th row. But the letters are the same, right? The Kate column and the column. The Kate column and the L column. But the rows are different, okay, from the others. That's what I mean by customize or customization. Okay, let's have another problem. Okay, so this one class, it only tells you that you're not, just like in part one. In part one, you're not only asked to get the, remember, this sheet here, the simple interest. So the same thing with the compound interest or the compound interest, the general. Let's look at this. Never mind this. This one, you're not only asked about the A or the capital I. Can also be asked about the P, the I, the N. But remember, I is what? I is equal to J over M. So not only I, but you can also be asked about what? J or M. How about the N? The N is equal to, remember this one class is equal to, okay, let me put here. The I is equal to, because what will you put here, class? The formula, not the formula based on this one. Okay, based on this one. What I'm saying is we have another formula, right? The I is equal to J over M. I is equal to J over M, right? And the N, we have what? N is equal to MT. So sometimes, not only the I, instead you'll be asked about the J. Well, how do you get the J? The I times M. No need for this one. Just get the I. After getting the I, multiply M by I. You get the J if you want the J. Now, for example, if you want the M, then you divide J by I. But usually what's asked, not the M, the J or the I. For this one, usually what's asked is the T or the N. But the N we have here. So first get the N. And if you're asked about the T, multiply M by T. You know M, right? M is the semi-annually. Semi-annually, so M is 2. Annually, M is 1, like that. Monthly, M is 12 because every month. So number of periods in a year. Quarterly, 4. M is 4 because every 3 months in a year, right? So usually what's being asked is the T or the N, but not M. But if M will be asked, that's also easy to get. N divided by T. N divided by T is M, right? For this one, if M is asked, J divided by I, that. Okay, so anyway, so that's why we can just focus here, the A pin. Just focus on the A pin, how to do. Okay, so I'll show you. Maybe there is a, for the P, it's easy to get, right? Because from, for this one class, you have to apply your algebra skill. Algebra. Okay, which you learn in high school. So this is I class, right? Look at the Excel. I mean the PowerPoint. You're asked about the J. So again, I told you, right? If you want to get the J, so we can just focus here. And then to get the J, M times I. But we can create formula. If you want, you can create formula here, but it looks complicated. You can create formula here. You can write here, if you want, you can write here J, or J is equal to, like that. But you have to write, you have to create this here. For me, it looks more complicated. So better just this one, the I, and then get the J from I. Okay, class? So now, let's try that. Let's have an example. We have an example here. Right? There, you see the I here? Then I was able to get the J based on the formula of this one. Okay, let's have a problem. Let's have a problem. So example, this problem. So class, this one, because I want to be consistent, so I replace R by J. So when you see here R, right? So what we mean is the J, okay? Okay, for this problem class, the approach here is very specific, very, very specific. So what we do in the Excel file, more general, because we want the formula. Okay, let me discuss first the Excel file. So since this one is, what do we want? Okay, so we have the principal, the 450. So the capital A is 750 based on the problem. Okay, and the T is 10 years. The M is 1. So what is N? Because what we want in the formula is what? A pin, right? So we have A, we have P, but we don't have the I. We want to solve the I in the Excel file. But here, what we want is the J. So our strategy is get the I, first and then get the j later. For this one, for this approach, for this strategy, they get the j immediately. So okay, let's see, let's compare. So if m is 1, what's the number of period? What is n? 10. N is 10. Okay, so let's put these values now. Let's go to that to the Excel file. So there, class. So you notice 750. That's the total. Principal 10. I got the I. I just follow this. This is the pattern. Look at the customized formula. Okay. Did you see the customized formula? L20 over M20, right? Because A over P. Okay. Then exponent, this one. Only this one, class. The 1 over N20. The 1 over N. Then the result there, minus 1. Now, if you're not sure, class, remember we only use parentheses. Isn't it what we want? Is the whole thing? Is it the whole thing, or just the minus? Let's look at the. Okay. Anyway, let us see if we will get the same answer. How do we get this? The question, class, is this. How do we get this? Okay, let me show you. Using your algebra skill. So this one, class, look at this. This one is the A-pin, class, diba? A-pin. However, I use here what did I use? The notation of Excel. So this is the A-pin. I want the I. So what do I do? So first, I divide this by P. Divide both by P. So I got this A over P. This one, the exponent raised to N. But the I is inside. So how do I get the I from the inside? So I raise this to 1 over M. That's why we have here 1 over N. Because N times 1 over N is 1. So in effect, this will become 1 plus I. This whole thing is raised to 1 over N. So now I can isolate the I. So you transpose this to the other side. So you get minus 1. Okay? So that's why we have this formula. Okay? Now, if you're not sure, class, because there might be a mistake, but if you're not sure, you can put here for this one, because this is not yet the. Usually what we do, we put bracket, right? We put the bracket like that. And then bracket here. But when you create, you cannot use bracket. You have to use parentheses. So to be sure, anyway, the colors will be different. Look, there. It will be black now. But the answer will be the same, class. Just in case you're not sure what the effect will be, and you're sure about this, the answer will be the same. Okay. Okay. So, since I'm sure that the answer is the same, I'll just remove this. Remove this one. Because the reason there, class, because the Excel file might treat this one minus 1, this whole thing minus 1. No, that's not what we want. What we want is this quotient is raised to 1 over N of 20. Then the result there minus 1. That's what we want. That's why we put the parentheses to be sure. However, the Excel file can recognize what we want. That's why no need for the parentheses. But again, if you're not sure what the Excel file wants you to do, just put the parentheses. As long as you don't use bracket, just use parentheses. But since I'm sure about the results that it's the same, so I will not put the bracket anymore. So I'll just remove it. But in your case, class, if you're not sure, just put the parentheses. But again, be sure where you put it. It should be the proper location, because if the location is wrong, the answer will be wrong also. So anyway, so now how do I get the J? Because what I want in the problem is J, not the I. So again, I told you, right? How do I get the J here? I times M, right? But the M here is 1. Remember, M is equals 1. So times 1, so the J is this. That's why the same result, you notice? 0.0524. We get the same result. 0.0524 also. Okay, class, did you notice the same result? Okay, another problem. By the way, for this one, class, as I mentioned, it's very specific, very specific. But the process used here is the same as this. In this one, remember, general, the same process. You notice we have 1 over N here. We raise it to 1 over N. This one, very specific. Raised to 1 over 10. Okay, 1 over 10. So 10 times 1 over 10, 1. That's why there's a 1 plus R. This one raised to 1 over 10. That's why we have this. Now, my problem with the solution is that, what if we're confronted with the same problem? You have to do this again. So that's why if you have the formula already, if you have the same problem, you don't need to do this again. All you have to do, what? What do you have to do? Just go to the formula and put the values, right? Where's the I? There, oh. Just put the values. and then enter, you can get this answer. I think this is the next problem. Let's look at the next problem. No, it's not. This is number of years na. Number of years. Okay. So so number of years. So again, for this one, very specific also. But let's look at the Excel file. Let's look at the Excel file. Again, if I want the t, I will solve for n, right? Because the n and the t are related. Where's the n? The n. The problem asks for t. So for our strategy, we will get the n, then we get the t. To get the t, n divided by m. Okay, class. So let's get the n first. But again, before we can get the n, we have to know the formula for n. So let's go back to the algebra again. So A pin, where's the A pin? This one, A pin, right? So I want the n here. So I get the n here, class, is exponent, I remember. So how do I get the n? So we have to apply what you learn in high school. Logarithmic function, logarithmic. But we will apply natural logarithm. Okay, but first, let's isolate the p. Divide both sides by p, a over p equals this. And then, so that the n can be isolated, apply ln to both sides. Okay, so there's a property of ln, which you have to recall. I cannot teach you anymore. But to recall, there's a property that if this is exponent, you can put this down here, multiply. The same result, the same effect. Okay, you can review that. And now we can isolate the n. Divide both sides by ln of 1 plus I. We get this result. So this one, I just copy paste here. So see, you notice, just copy paste there. So now I can use this as a pattern to create the formula. So here, so look at the formula. Okay, so you notice in Excel file, you cannot write small. It cannot recognize. It has to be capitalized ln. Okay, you cannot write the small ln. And I think the log, I cannot recognize the log also, just the ln. I may be wrong. Let me put the log. I think it cannot. It cannot. I think there is a log here. Okay, let me try log. I think it's okay to use log. So there's log. Because there is a log here. Okay. There is a log. So there. So let's see if the answer is the same. And then enter. Okay, it's fine. You can use log also. ln or log is fine. The same answer. Look at the problem. 14.2 years. So the same answer. Okay, class? So you notice about the ln, what I told you about ln there. If it's ln of, this one is more specific. ln 5 squared is the same as 2 times ln 5. It's a property of logarithm. So you notice, class, this one very specific because you have numbers. Where is that? I'm sorry. Very specific. You have numbers, but the process the same. You notice if you apply ln here also, we also apply ln here, right? Or even log is possible. Okay. But again, my problem with this is that what if you have the same problem? You will do this again. So instead of doing this again, all you have to do is just use the formula, right? Just put the given and you get the answer. I think the next problem has to do with this. But before that, class, look at the problem. It says here what? The investment is doubled. So in the solution, you see 2P and P. However, in our Excel file, we don't have that. We don't have 2P and P, right? Because in Excel file, we have to write the numbers. But we can write 2 and 1 because you notice here that P are canceled. In fact, as long as doubled, look at that. What did I put here? Where is that? Oh, there, 2 or 1. In fact, I can put even 200 as long as doubled or 20. So the same answer, class. 20, 10. Oh, the same answer. Even 2,000, 1,000, the same answer. Okay? Anyway, what we want is the t. Now let's look at the next problem. Okay, it asks for the t. So again, to get the t, what's our strategy? We get the n. So a pin, right? A pin. So to find the t, let's find the what? The a is the a given? Yes. The p is given. Okay. And the I, we have to get the I. Now, how do you get the I? This one. 0.075 divided by 1. Because annually, class, right? Annually. So 0.05 divided by 1 is 0.05. So our I is 0.05. How about the n? How do we get the n? That's the problem, right? We will look for n. Okay, let's go to the Excel file. So what's the A again? 45,000. Okay. A is 45,000. The principal is 30,000, right? Because when will the 30,000 earn interest, right? So the total is 30 plus 15,000, 45,000. Okay. So there, indeed, it's here. 45,000, 30,000, 0.075, and then this is the answer. Okay, look at the formula. Now, how do I get the t? So again, n is equal to what? N is equal to MT. Okay? So to get the T, N divided by M. N divided by M. But our M is 1, so 5.6, this 1 divided by 1 is this. So T is this. You notice the same answer. Okay, class? So that's how easy it is. Just do the A pin. Just do the A pin. So this one, class, is also A pin, I guess. It is also A pin, but this time it asks for the principal. Okay, principal. Is it? Is it the principal? Yeah, principal, present value. So let's, so this is the formula, class. It's easy, right? Let's look at the Excel file. So for the principal class, the algebra is easy. This is the algebra. It's easy, just 2 steps. Divide both by what? By this. You get the P. And then you copy here. Did you see here? And then there. Copy the formula. Okay? And then enter. Write the given here. Where did you get this given? In the problem, you have 42,000, right? The principal is 42,000. And then you have, how do you get the how do you get the I? In the problem, what is given? 5.6 compounded quarterly. So this one divide, right? 0.056 divided by 4 is 0.014. How do you get the N? This one. What is this in years? 3.75. 3.75 times 4, 15. So just substitute. You get the answer. And it's the same answer as this there, 34. Oh, that's a principal, class. 34,094,1577. But you notice there's a difference because this one is more exact. 0.16, right? I know, it's the same. Because if you round this off, 0.16. This one is 34,094, 0.16. Oh, it's the same answer. Okay. Yeah, I think that's the end of it. Yeah, that's the end of it. But before that, we still have time. I don't think we'll be able to discuss the other one, but we still have time. Before that, let me see. Okay, class. Let me show you the Excel file again. So for this one, we're complete, right? We're complete with the compound interest. So let me show you the other one. So this one, I already showed this to you, right, class? I already showed this to you. The A, the P, the I, and the N for the compound. And there, we have the more specific, right? This more specific formula for this one, the A pin. So we're able to get the formula for A here, the I, the N, no, the I, the I, the P. Yeah, do we have P? Yeah, the P is here. No, the P is here, class. Just different color. So it's complete. The formula is complete here. How about for the simple interest? Yeah, it's not complete now. So anyway, as long as you know your algebra skill, you can get. Okay, and you know how to apply it in Excel file, you can get the answer. Okay, class. I think that's it for today. So see you next time, class. Thank you very much for attending.